Hi and welcome. Now, in the previous video, we have already seen what is recursion and actually what is function calling itself means through an example and through a dry run. And a dry run is very important. If you have not seen this particular video, the link is in the description below. Fine. So now in this particular video, we are going to introduce and simplify recursion more, see the more basic terminologies and see the methods in which you have to think of the questions, think of the logic of recursion. Fine. So before we move forward in this particular video, do hit the subscribe button and press on the bell icon. So let's get started. Now, the next part in recursion is that we have to talk about base condition. Correct? So what is the meaning of base condition? So the base condition in this code which we have already seen is nothing but this particular part. If n equal to 0, return. So the base condition is used to stop recursion, because if we do not use a base condition, the recursion function will continue calling itself until the space is full, until the stack space is full. So the program will be stopped by the computer itself, not by because of our logic. Fine. So if we have to stop the function from calling itself continuously, we need to use a base condition. Okay, so we have to identify the base condition in every code. Okay, it will be a big part of our logic. Fine. So after the base condition, the next important part is how do we think of the logic of recursion. So for that, there are basically two methods. The first method is called induction hypothesis. Okay, and the second method is recursion tree method. Fine. Recursion tree. So this recursion tree method is widely used for many questions. It is used. Induction hypothesis method is also used for some easier questions. It is very well used, but mainly it is recursion tree. Okay, this is important method, a very important method. In this video, we are going to discuss about induction hypothesis because we are going to discuss about the basic questions of recursion, like sum of n digits, factorial, Fibonacci. Okay, all these questions will be solved using induction hypothesis. But since we are going to simplify recursion here, I am not going to talk about induction hypothesis a lot. Okay, I am just going to talk about the basic methodology to think on solving the simple recursion questions. So you can apply that for almost all the simple questions that you will be solving for recursion. In the next video, we are going to see about the recursion tree method. So let's get started with induction hypothesis. Now, if we talk about the first one, that is sum of n digits. Sum of n numbers. Sorry, not sum of n digits, sum of n numbers. Fine. Okay, so if n value is, let's say, 5. So sum of the first 5 numbers. Now I know you guys can solve it using loops, but here we have to think about how to solve this using recursion. Fine. So sum of first 5 numbers, that is 1 plus 2 plus 3 plus 4 plus 5, which is nothing but 15. Or sum of first 4 numbers, which is nothing but 1 plus 2 plus 3 plus 4, which is nothing but 10. Fine, that is what the question says we have to do. And we have to do this using recursion. So how do we do this using recursion? So first of all, get the base idea, get the base condition where you will stop. If we start with, let's say, n value equals to 8, so where we will stop, which you already know, so we have to find the sum from 1 to 8. Fine. So do we know 8 right now? What is the sum of the first 8 numbers? No. First 7 numbers? No. Do we know the sum of the first 1 numbers? Yes, we know. Okay, so if n value is 1, okay, we know the answer is always 1. So this becomes my base. That if n value is 1, I will return 1. This becomes my base condition here. Fine. Now, what else? Now, if you see this, we know that if we write a 5, sum of first 5 numbers is nothing but 1 plus 2 plus 3 plus 4 plus 5. Isn't this the same as writing sum of the first n minus 1 numbers, 5 minus 1 numbers plus 5? Correct? If I am writing 4, it is nothing but 1 plus 2 plus 3 plus 4. The sum of the previous numbers plus the number itself. If I talk about 6, so 1 plus 2 plus 3 plus 4 plus 5 plus 6. So sum of the previous numbers plus the number itself. Correct? So if I talk about n, so sum of the first n minus 1 numbers plus n itself. Okay, I hope you understood this basic maths. Fine. So sum of the first n minus 1 numbers plus n is my answer. Now what is the sum of the first n minus 1 numbers? Come on, you can write this. That is nothing but sum of the first n minus 2 numbers plus n minus 1. Instead of n, I am substituting n minus 1. Okay, similarly, instead of n minus 1, I can substitute n minus 2, and so on we can go. And when I reach sum of the first one number, I will directly return 1. That's it. Done. Fine, very simple. So if I write this out, okay, so I will write this using typing, okay, so all of you guys can understand, okay, instead of my handwriting. So let's start. So I know the sum, it will take an n as the input. Fine. And here we know that if n value equal to 1, we will return 1, because we are going for 1 to n, sum of 1 to n, return 1. Fine. If this is not the case, then we are calling the sum function, okay, but not just the sum function. What we are doing, n plus the sum of n minus 1. We are calling this, correct? Return n plus sum of n minus 1. That's it. This is what is happening. Simple. Fine. Now, if you want to understand it, I can draw a simple recursion tree for this. Okay. So what we will do, sum of 5. Okay, sum of 5 is nothing but if n equal to 1, no. So it is nothing but n, that is 5, plus sum of 4. Sum of 4 is nothing but 4 plus sum of 3. This is what is happening in the last line, n plus sum of n minus 1. 3 plus sum of 2. 2 plus sum of 1. And sum of 1, we know that if n value equal to 1, it will return 1, so it returns 1. 2 plus 1, 3, 3 returns here. 3 plus 3, 6, 6 returns here. 6 plus 4, 10, 10 returns here. 10 plus 5, 15, 15 returns here. And that is my answer. So this was about sum of first n natural numbers. Fine. Now just understand here, we find out the base condition. Okay. Then using the observations, what we are doing is we are going to formulate a particular method so that we call the same function again and again. Fine. The same thing happens in factorial. Exactly the same thing. So if you talk about factorial, if I go about 5 factorial, it is nothing but 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5. So it is also the factorial of first 4 numbers, that is first n minus 1 numbers multiplied by the number itself. So if I go for 6 factorial, it is nothing but 5 factorial multiplied by 6. Correct? If I go for 7 factorial, it is nothing but 6 factorial multiplied by 7. If I go for 3 factorial, it is nothing but 2 factorial multiplied by 3. Okay, 1 factorial, we know the answer is 1. Okay, 1 into 1 is 1, and 0 factorial, we know the answer is 1. Fine. So if n value is 1 or 0, we'll simply return 1. Okay, this we know. Fine. So this becomes my base condition, and here my factorial function, factorial of n, is nothing but factorial of n minus 1 multiplied by n itself. That's it. Over. So what is the base? That if n equal to 1 or n equal to 0, we return the value of n, that is 1 or 0. Else we simply return factorial of n minus 1 multiplied by n, and this gets calculated. Fine. So if we go for factorial of 4, you will understand it. So it will be nothing but factorial of, that is 4 multiplied by factorial of 3. This will be nothing but 3 multiplied by factorial of 2. Sorry, 3 multiplied by factorial of 2. This will be 2 multiplied by factorial of 1. We know the answer here. 1 factorial is 1 itself. 2 into 1 is 2. 3 into 2 is 6. 6 into 4 is 24. So factorial of 4 is 24. Fine. Okay. So again, the same process happened here. Same will happen with Fibonacci. You can pause the video and think about it. If we go for the Fibonacci series, fine, starting from 0. So the first term is 0, the second term is 1. All other terms are the sum of the previous 2 terms. So 0 plus 1 is 1. Then previous 2, 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13. And so on. Now, if someone asks me that what is the first term, that is nothing but 0, what is the second term, that is nothing but 1, what is the third term, that is nothing but 1, fourth term is 2, and so on. Okay, so according to this, I can directly write, depends if the question is going for 0 based or 1 based. Okay, what is your logic? Okay, you can start with the index 0, 1, 2, 3, 4 also. Okay, so we know that the first two terms, that if the position is 1 or the position is 2, we know the answer for n equals to 1 is 1 and for n equals to 2 is 2. And if you're going for 0 based indexing, then for n equals to 0, the answer is 0, and for n equals to 1, the answer is 1. Okay, you can find any of these two. So if we go for 0 based, n equal to 0 or n equal to 1, the answer is directly written in. Fine. And now, what will be for this particular point, n equals to 2? Okay, because we are going for 0 base, so I will remove it. Fine. So what you will do for n equals to 2? Come on. For n equals to 2, it is nothing but Fibonacci of n minus 1 plus Fibonacci of n minus 2. Same for everyone. For any Fibonacci of n, okay, for any Fibonacci of n, it is nothing but Fibonacci of n minus 1 plus Fibonacci of n minus 2, the sum of the previous two terms. So again, recursion, the same function is called again. Fine. That's it. Okay, this is the code I have here. It's a code. It's not difficult. Okay, so Fibonacci of n is nothing but if n value equal to 1 or n value equal to 0, we return n. Okay, else we return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Fine. That is done. Okay, this is when we are starting the positions from 0. Okay, you can start the positions from 1 and accordingly change the base condition. Fine. Okay, so we have discussed three things here. Okay, and in all the three things we have used something called induction hypothesis, but I have not explained induction hypothesis. Okay, if I explain induction hypothesis, fine. Now since three examples we have taken, so in induction hypothesis, first we find out for the smallest value what is the answer, because we know it. Okay, for example, in factorial we know that 1 factorial is 1, 0 factorial is 1. Fine. For Fibonacci we know for n equals to 0, for n equals to 1 what is the answer. Okay, for the smallest value find out. Then we hypothesize, we assume that we know the answer for n minus 1. Okay, or the recursion function will definitely give the correct answer for n minus 1. And using that hypothesis, this assumption, we find out what is the answer for the value of n itself. Okay, we did this in everything. So in the sum of n, okay, when we call by the sum of n, okay, we write it sum of n minus 1 plus n. Correct? This is what we did. Fine, n plus sum of n minus 1. So we hypothesize, we assume that this will always be correct, and this will be calculated similarly. And now in this we hypothesize, we assume that sum of n minus 2 will be given the correct answer. Fine. So that's why I said, even if I do not explain what is induction hypothesis, okay, the process remains this only, that you need to find out the smallest possible base condition. Okay, and using that particular smallest possible base condition, then you need to find out a particular logic. You need to just observe it out. Okay, and using that, you need to think on the solutions of recursion. Fine, that the same thing is happening again and again, so I can call it in a function. Okay, and I can call the same function from the function, so function calling itself. Fine. So this was the second video of recursion. In the next video, we are going to see about recursion tree. This is very important. Okay, most of the questions will be solved using that recursion tree approach. But how to think of such questions is very crucial. Okay, so if you like the video, do share it with your friends, your batchmates, your classmates. Okay, do subscribe our channel. Thank you so much. Bye bye.